Hey everyone, D. Dykstra here with another great video from math. We have got a little pre-calculus stuff here today. We're talking about end behavior for functions, and more specifically we're talking about the leading coefficient test. What do some of these graphs start to look like as we start diagnosing their components? I'm one to go and look at the function first, see what their leading coefficient is. Is it positive, negative? What is the leading term? The leading term will determine a lot of information about it. Is the power of the exponent, is it positive? Is it negative? What could it be? If it's negative, that means it may not be a polynomial. It's probably not a function, but because you're dealing with some asymptotes there and so forth. But it could be a function. Anyway, we won't get into all that. Here's what we want to look at. Little chart, right? Here we got a little chart, and we see that if we look at the a value of your polynomial, a to some x to the nth power, right? I'm going to scoot this over. If I look at this leading coefficient, this is your f of x equals your a times x to some nth power. Well, a is your leading coefficient. So we've talked before about in parabolas, if it's a negative out front, it's going to be facing down. And you might have seen that if it's positive, the parabola is going to be facing up. Well, really no different here, except now we're just dealing with higher powers, cubics, quartics, etc. So this n value, as it increases, what happens to the function, how many turns do we get out of it, etc. All right, so a little chart I've got to help us describe this, what's going on. If the a, or the leading term, is positive, right, or what happens to the n behavior if it's negative, as well as if n is odd. Now, n is the exponential power, and if n is even. All right, so let's talk about each of these real brief. If n is odd, then you will have a function where the n's go in opposite directions. Okay, the n's go in opposite directions. If it's a positive a, right, that leading coefficient, then it will be positive on the right-hand side and negative on the left-hand side. This is what we call rises right and lowers left or drops left. Okay, so we rise right or we fall left. You might see it that way in some books, where we rise right and we fall left. Okay? If that's odd, again, we go in opposite directions. If a is a negative out front, then you'll see that it will rise left or rise to the more negative side of the graph and fall to the more positive side of the graph. And that's kind of the way I think about it in general. Is this just keeps me going right here. If it's positive, it's going to rise on the positive side of the spectrum. Okay, the more positive number. If it's negative, it's going to rise on the more left or more negative side of the spectrum and then go the opposite direction. So, I mean, that just kind of helps me keep it in frame of reference when I'm doing these things. Now, if n is even, if the exponential power is even, we will see that the n's will behave the same. They'll go in the same direction. If a is positive, they will both point up. Just think of your classic parabola, y equals x squared. It's an even, and what happens? They both go up, right? When it's negative, the parabola points down. So we get this down feature. Same way here. All right, so this is kind of a little chart to show you that information. Some other details here. How to determine if odd or even. Well, I mean, we're math, so hopefully we know what odd numbers are and even numbers are. But just in case, let's review. If n is odd, that's a 1, 3, 5, 7. Easy for me to say, right? Okay. If n is even, that's 2, 4, 6, 8, etc. So that's how we know. The odd functions will be cubics, maybe to the 5th power, to the 7th power, etc. Your even functions are your quadratics, to the 4th power, to the 6th power, etc. Now, what will determine the number of turns? N minus 1. Well, n is the power, and so we get that n minus 1. So that will determine the number of turns. All right, so let's look at a couple examples. Use the leading coefficient test to determine the end behavior of the function and sketch a quick graph, right? So we get y is equal to negative x to the 4th plus 8x cubed plus 4x squared plus 5, or plus 2, excuse me. A, in this case, is negative, right? It's right there. It's negative. N is an even number, so that means they're going to be in the same direction. And n minus 1, or 4 minus 1, is 3 turns. Now, because it's even, I know they're going to both be pointing down, and it's n number of turns, so I start on my left, it's pointing down. I'll go up 1 turn, down 2, and over 3 turns, and down to the 4, and so it looks like an M, right? And that's the classic look for a function to the 4th power. Next one is y equals x to the 5th. So we have positive x to the 5th, plus 3x to the 4th, plus 8. You notice I don't really care what's happening back here. The rest of these, they don't do much for it. What really determines everything is this leading coefficient, that leading term. So it says, oh look, a is positive. Yes, a is positive. N is odd, so they will go in opposite directions. And n minus 1 is 4, so 5 minus 1 is 4 turns. So because a is positive, I will be positive more I will be going up in the more right-hand side of the more positive, and I will be falling left, right, or falling to the left side. So I know if I'm falling left, I can come up, I can go 1 turn, 2 turns, 3 turns, come back down, 4 turns, and finally go back up to 5 turns. And that helps me establish a baseline of what this thing should look like. All right, now this might not be this function entirely. If you graphed it, it might not look exactly like this. I'm not trying to say that it looks exactly like this. This is not to scale. This is just giving you an idea of what is happening with these functions given this leading coefficient and leading term test. All right? Well, I hope that's been of some help. This has been end behavior of polynomial functions and the number of terms. Hope you have a great night. Thanks again. Peace. D. Dykstra out.